Okay, great. So hi, everybody. Thanks for having me today. My name's Tagwongo, which means autumn in Abenaki. I graduated from the University of Maine in 2015 with a degree in economics and a concentration in renewable energy policy. I attended this conference when I was a student here, so it's nice to see some familiar names and faces. After my undergraduate, I found a job at Ocean Renewable Power Company, where I work as their market development manager. I perform market research, financial modeling, and competitive analysis and various odds and ends. I also recently decided to pursue an MBA, and I'm currently in my second year. I was drawn towards a career in renewable energy because I love the environment, and I think all the living things on Earth deserve to have clean air and water. And not only will a rapid transition to renewable energy and electrification help ensure those things remain available, but breaking free from fossil fuels can help move us away from an extractive paradigm that is unsustainable in every way. And as we all know here, the future is bright for renewable energy. So today I'm going to spend some time talking with you all about a kind of renewable energy that some of you might not have heard of, which is marine renewable energy. So marine renewable energy power systems convert the kinetic energy in moving water into renewable electricity. And Ocean Renewable Power Company develops underwater power systems that generate electricity from tidal and river currents without the use of dams or impoundments. Tidal energy is predictable and highly reliable. It is a variable resource over a 6-hour cycle that makes the energy output easy to accommodate in both utility scale and local applications. Energy from river and deep water ocean currents is similarly predictable as a continuous resource with minimal fluctuations in power output. And as we get closer to 100% renewable energy, we need to balance wind and solar with predictable and highly available sources of energy, as well as energy storage, and this could come from tidal energy. We also need energy sources that are local, and major population centers are often located near water bodies. These technologies can play an important role in the energy transition, and when integrated on reactive power grids that balance both energy generation and use, these technologies will help transform the electric grid into the resilient and decentralized grid of the future. In Maine, there's a significant tidal energy resource at the mouth of the Bay of Fundy, and smaller resources are located in various spots along the coast. It's certainly not going to provide all the power to the state, but it can make an important contribution locally for some communities. Ocean Renewable Power Company is a leader in this industry, and the company was founded and has a long history right here in Maine. We're based in Portland with a Marine Operations Center in Eastport and an engineering and electronics laboratory in Brunswick. Over the last decade, Maine's coastal communities have been a proving ground for innovative tidal, river, and offshore wind energy systems. Eastport, Maine has been a partner to ORPC as we have developed, tested, and refined multiple iterations of our technology. Beginning in 2010 with the Beta TideGen, ORPC tested its full-scale TideGen power system in 2012, which was an important milestone for the industry. Throughout our history, community members have been actively involved in the siting, assembly, installation, and monitoring of our projects locally. ORPC's success in Maine and elsewhere would not have been possible without state and local support in the form of regulatory action, direct funding, and research and development support. These successes are directly related to our ability to develop and test our power systems in Maine, facilitated initially through the Ocean Energy Act of 2010. As a result of the act, the Maine PUC granted ORPC an allocation of tidal energy generation of up to 5 megawatts, which has been key in driving continuous progress towards developing a commercial tidal energy project in Maine. Maine state regulators, including the Maine Department of Marine Resources and Department of Environmental Protection, helped to develop the adaptive management process for permitting and licensing marine energy projects, which has been successfully replicated in Alaska. And the University of Maine has also been integral to our success. The School of Marine Sciences has helped to design and implement research to answer key questions about the potential environmental interactions with the TIGEN power system. This research paired scientific data collection with community observation to understand how fish and marine mammals might react to the presence and operation of submerged tidal energy turbines. And the results have been crucial in de-risking the technology in the eyes of community stakeholders and regulators. The Advanced Structures and Composites Center has also overseen critical component testing, where we conducted an accelerated wear test on the RivGen driveline to understand potential component failures over the system's simulated operating life. And last year, we also utilized the wave tank test to test a scale model of the autonomous turbine generator unit. ORPC has also invested in the state, with over $40 million spent as of this year, helping to create jobs and build local expertise, and over $6 million spent in Washington County alone. We contracted Down East Machining and Engineering to build the first RivGen device that is now operating in Alaska, and the second one is being built and assembled by DEEM as we speak. We also have a power purchase agreement in place with the regional utility serving Eastport, which actually came about as a result of the Ocean Energy Act. And uniquely, this PPA was designed with an economic development tool in mind. It required the establishment of a Maine-based ocean energy industry with an in-state supply chain, host community partnerships, and R&D participation by the university system. So we're proud to have fulfilled the promises of the PPA, and we remain committed to doing so in the future. And we're bringing our Maine proven technology to market across the country and around the world. ORPC is bringing its power systems to market in communities that are not accessible by major roads and are not connected to regional electric grids. Over 700 million people worldwide rely exclusively on diesel generation for their electricity, which requires fuel to be barged, trucked over long distances, or flown into these remote areas, as you can see happening right here in this picture on the left. As a result, their cost of electricity can be up to 10 times what we pay in the continental US. Remote mining and other industrial facilities face these same issues. Tidal energy and river energy can serve as a baseload renewable power source to offset diesel use and complement intermittent or seasonal power production from wind and solar. In this community of Igiagig, it costs 77 cents per kilowatt hour to generate electricity, and fuel prices can exceed $7 per gallon. The state of Alaska spends over $1 billion per year subsidizing electricity prices across hundreds of rural communities like Igiagig. And in addition to the cost, diesel poses significant risks to the environment and human health. The RivGen currently deployed at Igiagig is now the longest operating river current energy converter in the Americas. We survived 2 Alaskan winters where temperatures dipped below -40, as well as 2 frazzle ice events and a spring ice breakup. And if you've never heard of frazzle ice, it's what happens when the water is so cold that ice starts to form in the middle of the water column and then floats to the surface, creating something a little bit like an underwater blizzard or a slushy. The ice can accumulate on things and float them to the surface, which is somewhat concerning when the thing just happens to be a 30-ton power generation machine. Luckily, we were able to develop a mitigation strategy that involved spinning the turbines in freewheel and shaking the ice off. And we're happy to say that we survived 2 of these events now, proving the durability of our system. We've also collected hundreds of hours of data from various technologies, including hydroacoustics, imaging sonar, and video, which have indicated no observed injuries or mortalities to fish. During the 2015 RivGen power system deployment in Igiagig, research showed that nearly 2 million sockeye salmon swam by or through the RivGen turbines without any evidence of barrier to fish passage. Our success in Alaska and Maine is driving new opportunities for ORPC domestically and abroad. In addition to our Igiagig project, we have similar efforts underway elsewhere in Alaska and in Canada and in Chile. And since our beginnings in Maine, we've grown as a company. Starting from 3 employees in Maine, we now have 28 employees in our offices in the US, Canada, and in Ireland. We've built on our successful R&D partnerships here and have been highly successful in winning competitive grants from the US Department of Energy, the European Commission's Horizon 2020 program, Polar Knowledge Canada, and others. And in addition to the University of Maine, our research partners include the University of Washington, Alaska, College Cork, Ireland, NREL, Sandia National Labs, and many more. And our work in Maine continues. I mentioned earlier that we tested our autonomous turbine generator unit at UMaine's Wave Tank, and it was also tested in the open ocean environment in Eastport. And this was all accomplished during the pandemic, of course, which made already complex logistics even more challenging. But our partners rose to the challenge and the work was conducted safely and without incident. Under a new DOE award, we're also going to be testing our next generation RivGen device, the modular RivGen, at a river site in Maine. And we will be demonstrating the next generation of TiGen devices in Eastport as well. The next generation TiGen will be integrated into an exciting new project that we're calling the Eastport Smart Microgrid Project. First, what is a microgrid? So starting with the regular grid, which connects our homes, businesses, and other buildings to central power sources and allows us to use appliances, heating, cooling systems, and electronics. But this interconnectedness and centralization means that when a tree falls onto a power line, everyone is then affected. And this is where a microgrid can help. A microgrid generally operates while connected to the grid, but importantly, it can break off and operate on its own using local generation in times of crisis, like storms, falling trees, power outages, or for other reasons. A microgrid can be powered by distributed generators, batteries, and renewable energy sources. The microgrid not only provides backup for the grid in case of emergencies, but it can also be used to cut costs or to connect to local resource that is too small or unreliable for traditional grid use. A microgrid also allows communities to be more energy independent and in some cases more environmentally friendly. Depending on how it's fueled and how its requirements are managed, a microgrid could even run indefinitely, relying entirely on local generation. The tidal energy potential at Eastport can create a predictable and reliable baseload renewable power source for the community. Eastport is at the end of a 40-mile-long transmission line that is exposed to bad weather. When bad weather occurs, the town may be without power for several hours until the utilities crews can make repairs. In the past, there was a backup generator to keep the lights on until those repair crews arrived, but the generator failed over 2 years ago. Versant Power strengthened the transmission line feeding Eastport in 2018 to improve reliability, but the generator was not replaced. So, ORPC, the City of Eastport, and Versant Power have come together to partner on a smart microgrid initiative to make use of the abundant local clean energy source and improve the reliability of energy service to the town. The project could integrate multiple sources of renewable energy, such as tidal power, and distributed or utility scale solar power with energy storage and smart controls, providing a community scale baseload renewable energy solution. The microgrid would operate seamlessly with the Versant regional grid, replacing the former diesel backup substation and reduce the need to spend unnecessarily on poles and wires. This collaborative initiative would showcase local solutions to meet the goals of Maine's climate action and clean economy plans, as well as the megatrends in the electricity industry at large. And as this project begins to take shape, we look forward to sharing many more exciting updates with you all. So to conclude, ORPC looks forward to continued partnership with Maine communities and institutions. We've seen that our projects in Maine and Alaska are addressing head-on the megatrends that we're seeing in the energy and electricity industry today. We know that tidal energy has the capability to provide a baseload renewable energy solution to help unlock a 100% renewable energy future for coastal communities. And finally, Maine has been an absolutely essential piece of the puzzle in the development of the tidal energy industry nationally, from proof of concept, proof of environmental and social acceptability, and now its commercial viability and international relevance. So with that, I want to say thank you so much for your time, and it's been a pleasure.